With the advent of digital video, we quickly found out that we needed to compress these digital files in order to play them back on a PC and transmit that over a network. So imagine your digital camera once again. When you take a picture, say a 3 to 5 megapixel digital image, that creates an extremely large file. And video is just a sequence of digital stills. So take that file, say it's probably 1 meg, and multiply by 30. That gives you a 30 megabyte file. Try to transmit that over your 56K modem. And so research started to employ digital compression technologies in order to take these images down. And there's two types now. There's inter-frame, which means that I'm going to compress this digital image within itself and then from frame to frame. So let's talk a little bit about digital stills first. And so when you see an image on the internet today, it's generally either a JPEG or a GIF file. There's some other ones out there, but those are the two predominant. And so if you take an image such as this skyline here, you notice there's a lot of blue in this image. In fact, the whole upper half is blue. And so if I look at the binary file itself, each one of these pixels, all these blue values are the same. Well, why would I send 400 blue in a row when I can just say send 400 blues? That allows for a tremendous amount of reduction in file size. And in JPEG and GIF, you'll commonly see 25 to 1, 40 to 1 over the original size. So if I showed you the original file versus the compressed file, your eye doesn't differentiate a lot between the two. And so that allows for a very huge reduction in size of image. And if you multiply that across 30 frames, you get a significant reduction in file size. And so using this example here where I've got 2 frames of video, so you've got a lot of area in frame to frame that's not changing. And so why should I send imagery that's not changing? So we only send the changes across in a video file. And so that allows for even greater compression. So I get 20 to 40 in INTRA-FRAME, and then adding the inter-frame compression, I can get 300 to 1, 500 to 1 compression ratio with Windows Media 9 and H.264, which are the 2 predominant video compression technologies on the market. And we're agnostic, and so we support them all. And so utilizing these very sophisticated discrete cosine transformation, wavelet, all this type of calculus that you might have learned in college and said, when am I ever going to use that? This is an example of an application that uses very sophisticated calculus in order to shrink these files, send them across, and then uncompress them on the receiving end. And that kind of birthed the whole streaming marketplace. So we use these very sophisticated technologies that compress and decompress kind of behind the scenes, and that really is the birth of the streaming market today. So with that, this kind of gives you an example of where we've come since 1941 with the NTSC analog, converting that analog video into digital like I'm doing right now. You're watching an analog camera that's fed into a digitizer which converts it into a digital format, then is compressed with Windows Media 9, and then uncompressed as you view it today. So with that, I'll see you soon.